It is Saturday morning, and we want to talk about questions 8 through 10 on data assignment 3. All right. So I did not do 5, 6, and 7, but I think they're very similar to number 1 and to number 1, 2, and 3. So I will skip that, but I did get an email about 8, 9, and 10, I believe. So I'll go ahead and go over these in this video, okay? Explain why it was not necessary to examine the normality assumption for sample 2. Now, we looked at 2 samples. Sample 1 had sample 1 size is 25 and sample 2, whoopsies, size is 50. You want to see a cool way to write the sample size for these 2 samples? You can do n with the subscript. I'll show you. We can say n1, sample size for sample 1 is equal to 25. And this is just some extra, but I think we have to talk about these 2 different sample sizes when we get to chapter 8, so why not? So we have 2 different sample sizes. So how come we get to skip checking the normality assumption for sample size of sample 2 who had a bigger sample size, right? So what's the theorem? What's the name of the theorem here? Okay. All right, I'm sorry. I'll show you where we can find that. I want you to go to 5.4. That's when we started talking about sampling distribution. And what is the section name? Sampling distributions and the central limit theorem. So number 8, I want you to talk about the central limit theorem, okay? Which is saying, slide number 14. If samples of size n greater than or equal to 30 are drawn from any population, see, it doesn't have to be, the population does not have to be normal, with mean mu and standard deviation sigma, then the sampling distribution of the sample means approximates a normal distribution. That is why for sample size 2, or I'm sorry, sample 2, whose size was 50, we can go ahead and just use the central limit theorem, and we don't really have to examine the normality assumption because the sample size is already 50, it's greater than 30. The sampling distribution of the sample means approximates the normal distribution. So that is how you can type it up, okay? I want you to give me the sentence, okay? The greater the sample size, the better the approximation. And the reason is because, why is this blank Word doc open? Because 50 is bigger than 30. That's why we get, I want you to type it up. I just have I have a baby on my left hand, so I can't really type it with both hands right now. So that is why, so that was number 8, okay? So I want you to mention the central limit theorem and talk about the sample size of 50. Alrighty. Why is the margin of error lower? Hold on. Why is the margin of error lower for the interval you constructed using sample 2? Let's go grab those margin of errors, okay? Because I really want to see if it was actually lower. Margin of error from sample 1 was equal to, let's go back up and find it, this number. Margin of error for the second sample, a second confidence interval, I just realized I never found it because I skipped number 5. So maybe I will do that real quick. Okay, give me 1 second. So I can go to my StatCrunch, upload data, whose sample size was 50, do a quick confidence interval by going to stat, tstat, one sample with data, click on height, 95, compute. So this is my answer for, I believe, number 5. I'll go ahead and just post that over there. But I think I skipped this because you and I did this together on number 1. But now I can just find the margin of error while at it. Okay, margin of error equals upper limit of 162.88 minus 159.96. Of course, your number is probably different, but I need to have my numbers so that I can compare this margin of error with the other margin of error that we found. This came out to be 2.92. 2.92. So down here I say 2.92. Now listen, both confidence intervals were 95% confidence interval for population height, okay, average height for the population. But how come the first one has bigger margin of error compared to the second one? What was their difference? Okay, remember the sample size for the first sample was 25 and the sample size for the second was 50. So what we see is this, look, the bigger the sample size, the smaller the margin of error. So I want you to just type that up. Look up the, well, you may also Google it. Look up the relationship between the margin of error and sample size. What I saw is that if we have more people in our sample, we're gonna have a better or a little more accurate confidence interval with a smaller margin of error. Okay, so as sample size increase, the margin of error decrease. You can write that down, or you can really Google search margin of error and sample size. Let me go to Google and just, the relationship between margin of error and the sample size is simple. As the sample size increase, the margin of error decreases. This is the sentence you want. Why is this true? I do want to show you why, because if we open up 6.2 slides, I'm going to show you the margin of error formula real quick, okay? This is the lesson that you guys did by yourself. I'll go ahead and talk about this. I found the margin of error formula right here. This is it. And I'll bring it over here so that we can talk about this. Where do you see n? Where is n in this formula? You notice how n is in the bottom of the formula, right? Okay, so what's happening is this. If you divide by a big number, okay, if you divide by a big number, the quotient will be small. Does that make sense? If you have like a $5, but you divide it to 5,000 people, each of them get a very small amount, right? So as the bottom of the fraction increase, as the denominator of this quotient increase, of course the quotient is going to get smaller. That's why if you want to talk about the formula, but all I really wanted was that one single sentence that says, as the sample size increases, the margin of error decreases. And that is because when we find the margin of error, we are dividing by the sample size, the square root of a sample size. So the bigger the number that we divide by, the answer to the division will come out to be smaller. So I want you to just summarize that up for me, and that is going to be your answer for number 9. Okay, let me see if there was another question. And number 10, and that will be my last one, and I'll just wait for you to email me if you want to see anything else, okay? If you construct 3,000, whoa, okay, we're gonna make 3,000 confidence intervals, huh? 3,095% confidence intervals from 3,000 different samples. How many of them would you expect to contain the actual mean height for all students in the database? Think easy. You know the answer already. Now, if you make 3,000 confidence interval, how many of them will capture the true population mean? 95% of them will capture the true population mean. So what is 3,000 times 95%, which in decimal is 0.95? And how about I ask you to finish that one up, okay? So it's gonna be a number, blah, 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 that many of them, I guess it's like 2,000 something, will capture the true population mean, but that is how you can do this. If you wanna be 99%, you will change that to 0.99, but that is how you would do number 10. Now let me know if you need anything else. I'm gonna go ahead and stop the recording, and I will process this video and put it on YouTube for you, okay?